Hi everyone. So in this video, I'm going to be solving out some of the homework problems. So this would be helpful as you actually do some of those recommended homework problems. And so then you can actually see if you're doing it well or not, So hopefully this will be helpful for that. So I've basically listed the problems that I'm attempting. These are 2.1b and 2.1e. These are for converting these condensed structural formulas into Lewis structures. And then I'm going to be doing 2.5J, which is for converting a condensed structural formula into a bond line structure. Okay, so this is 2.5J. So these are the three problems. So like I said, the first two are for converting a condensed structural formula into a Lewis structure. So let's start reading these structures. So what we see here is we have a CH3, CH2 in parentheses twice that's connected to a CH. So if it's helpful, okay, you could actually write this or basically rewrite this structure. Okay, so how do I read this structure? So I'm going to read this as a CH, this CH, it is connected to two of these groups. So I can write that as CH3, CH2, and then I have another CH3, CH2. And this might be helpful as you start out doing these problems, and later you will slowly realize that you don't really have to do this. So you have CH, and then we have CH2, CH2, OH. So that's the condensed structural formula now. So now basically see a little bit more of the connectivity in this structure. So it should help me write it out better. So this structure, when I convert it into Lewis structure, I hope I'll have enough space over there once I convert to Lewis structures, because realize Lewis structures are sort of cumbersome to write. So starting off with a CH3 that's connected to a CH2. So I have carbon connected to a carbon. This is a CH3. Then we have a CH2. That CH2 is connected to a CH. So I'm going to actually put a CH over there. Okay. Now this CH is connected to another CH2, which is connected to a CH3. So from that CH, I'm going to go down and write another CH2 and a CH3. So you notice how I went down, and that's because of space. Okay. Now I could write it at angles the way it's here, but either way is fine. So I have the CH now. After that, we have a CH2. And then another CH2 and then an OH. So CH2 and then an OH. Since this is a Lewis structure, I will include those lone pairs on the oxygen. So when oxygen makes two bonds, it should have two lone pairs to it. So this would be a Lewis structure for this, for the given condensed structural formula. Let's try to do the same for this structure here. Now for this one, notice how we have a CH2, then a double bond, CH, CH2, O, CH2, CH. And then that CH is connected to two CH3 groups. That twice, the fact that the CH3 is within parentheses with a twice on it, that tells us that they're both connected to that carbon. Okay, so let's start writing it out. So I have a carbon with two hydrogens to it, double bonded to another carbon with one hydrogen. Then we have CH2 connected to an oxygen, connected to another CH2. Then we have a CH, and the CH has two CH3 groups on it. So we're going to write CH3, and the CH is also connected to another CH3. Okay, so that will be the structure. The oxygen has two lone pairs. So that would be a Lewis structure corresponding to the given condensed structural formula. So as you see, these, I mean, the condensed structural formula and the Lewis structure, they give us the same information. The condensed structural formula is definitely, as the name suggests, a little bit more condensed, so it's easier to write. But the important thing is we should be able to read the connectivity properly. Okay, you have to know which atom is connected to which other atom, you know, what sort of bonds are there, things like that. Lone pairs, does an atom have lone pair? We should be able to predict that based on our understanding of octet rule and formal charges and things like that. Okay, so those were the two problems for converting condensed structural formulas into Lewis structures. Now let's go ahead and convert this condensed structural formula into a bond line structure. So to do that, what I'm going to do is I'm going to count the carbons and basically locate where the carbons are. So we have 1 carbon, 2 carbon. The second carbon is actually connected to an oxygen. And then we have a third carbon. So third atom is an oxygen. Then we have a carbon, carbon. And the CH here is again connected to 2 CH3 groups. Okay, so how are we going to write this? If this is my first carbon, that's double bonded to the second carbon. And remember, we do not show carbons or hydrogens in a bond line structure. Every endpoint and every corner is a carbon atom. So CH carbon double bonded to a carbon. So I'm going to start off by just drawing a double bond. Okay, a double bond. So this is the CH2 and that's the other carbon. This is carbon is now connected to an oxygen. So I'm going to show an oxygen over there, which is connected to another carbon, this carbon, and then another carbon. So the C here, and this carbon is connected to 2 CH3 groups. So from here, I'm going to draw 2 groups like this. So this bond line structure is the same as this condensed structural formula. So let's just make sure that everything matches up. So if you look, we have overall 1, 2, 3, 4, 5, and 6 carbons in the condensed structural formula. And we have 1, 2, 3, 4, 5, and 6 carbons. Oxygen is between this second carbon and that third carbon. That's where the oxygen is. And now you can basically, if you want, you can also count the number of hydrogens also. This carbon here has 2 bonds to it already. So it should have 2 hydrogens. That's a CH2. This carbon here has 2 plus 1, 3 bonds to it. Needs only 1 hydrogen, CH. Oxygen, no hydrogens on it because it has 2 bonds to it. Then the carbon over here has 2 bonds to it, must have 2 hydrogens, so CH2. This carbon here has 1, 2, 3 bonds to it, so it needs 1 hydrogen, so that's a CH. And then each of these end points, those are 2 carbons with 3 hydrogen atoms. So we basically converted that condensed structural formula into a bond line structure. And notice how easy it is to draw a bond line structure. So I hope this is helpful, and as you practice some of the homework, you could use these examples as guiding examples if needed. You know, I'm sure you'll all be able to do it, but if needed, you can use this to verify your work. Bye.